In today's exploration of the unit circle, we're going to talk about what are called even and odd functions. So an even function is a function that if I were to substitute in a negative value, a negative value, I would still get the same y value if I plugged in the positive value of that instead. So for example, if we were talking about f of 3, does that equal f of negative 3? If those two are the same, then you would have an even function. So our good old friend, the quadratic function, the y equals x squared, that is an even function because if I substituted in 3, I get positive 9, and if I substitute in negative 3, I get positive 9. Now, not all quadratics are even functions, but this one is because I can substitute in negative 3 and positive 3 and get the same value, and that's true for any number. I could substitute in 5 and negative 5, and I would still get the same value. So for our trig functions, what we're looking at is if I substitute in an angle, do I still get the same value if I substitute in the negative angle of that? And remember, negative angles go in a clockwise order or clockwise direction. So if I have my coordinate plane and I have the angle here of pi over 3, we'll say that this angle is, our theta is pi over 3, and then our negative angle, we'll say, we'll do theta is negative pi over 3. So the cosine and secant functions are even. Cosine and secant functions are even because the cosine of pi over 3 is 1/2, and the cosine of negative pi over 3 is also 1/2. Okay, because remember in quadrants 1 and 4, the x values are the same. So cosine is even, which makes secant even. Now, sine is not even because the sine of pi over 3 is the square root of 3 over 2, and the sine of negative pi over 3 is negative square root of 3 over 2, because in quadrant number 4, our y values are negative. So sine is not an even function, which makes tangent not an even function because tangent is sine over cosine. Since sine isn't even, tangent can't be even. An odd function is if I had f of the negative angle equals negative f of the angle. So in like normal numbers, if I had f of negative 3, does that equal negative f of 3? So in this instance, it's almost looking like the even function, but we have a negative on the outside. See, f of 3 equals f of negative 3. This is f of negative 3 equals negative f of 3. So the odd functions are sine, tangent, cosecant, and cotangent. And let's look at that. So if we have this, pi over 3 still, and we say, okay, the sine of negative pi over 3, well, the sine of negative pi over 3 is negative square root of 3 over 2. Is that equal to the negative sine of positive 5 pi over 3? Well, the sine of positive 5 pi over 3 is the square root of 3 over 2, but because we have a negative in front, it would become negative. So yes, this shows that sine is an odd function. And then let's go in further and look at tangent. The tangent of negative pi over 3 is going to be negative square root of 3. And then the tangent, the negative tangent of positive pi over 3. Well, the tangent of positive pi over 3 is a square root of 3. Negative in front makes it negative square root of 3. So again, since these match, this is an odd function, which means the reciprocal functions are odd too, cosecant and cotangent. So we can use these facts of even and odd functions to evaluate evaluate the trig functions for angles a little bit quicker. For example, I always was telling you that with negative angles to add 2 pi to make sure we have it on our unit circle. But if we know that cosine is even, and I ask you, oh, what is the cosine of negative pi over 4? Well, you know that if you do cosine of positive pi over 4, that they'll be the same value, and that way you wouldn't have to do the work to get that coterminal angle. You still could do that, but this will get us our answer just a little bit quicker. So down here, what we have in example 1, it says, okay, if our sine of t is 1/4, then what is the sine of negative t and the cosecant of negative t? Well, remember, sine is odd, which means we'll have the opposite sign. Like up here, okay, our odd function, we have f of negative 3 equals negative f of 3. So we have sine t of 1/4, then sine of negative t is going to be negative 1/4 because it was opposite. Remember, a lot of times in math when you see that negative sign, it doesn't necessarily mean negative, it means opposite. So then we can take that further and say the cosecant, well, we know cosecant is sine flipped, so that's going to be negative 4. Sine of negative t equals positive 2/3. That is sine, which is odd, so it's going to be opposite signs. So that means the sine of t is going to be negative 2/3, and the cosecant will be sine flipped, so negative 3/2. Then we have cosine. Cosine is even, so it will be the same. So if we have the cosine of negative t is negative 2/5, that means the cosine of positive t will also be negative 2/5. And the secant will be cosine flipped, so negative 5/2. So if we look at the last one, sine t is 4/9. Notice I have addition and subtraction inside my angle. So to help us with these problems, let's draw a picture. Okay, so 4/9, if sine of t is 4/9, then the angle is somewhere in quadrant number 1. So this is t, our angle. Then if I look at sine of pi minus t, well, pi is 180 degrees, correct? Like this would be pi. But now if I subtract that angle t that I drew over here, it's going to come up like this. So then this is my actual angle because I subtracted this angle, which was t. Well, our y values in this quadrant, because my pink angle is my angle we're asked about, that y value is still going to be positive. So it's going to be 4/9. Now the general rule when we have sine of pi minus the angle, what that does is that it moves the angle ahead 1 quadrant. So my original angle was in quadrant 1, and then I did pi minus that angle. I moved up 1 quadrant into quadrant 2, but sine is still positive in that. Then we have sine of t plus pi. So it's going to be similar where pi is our half circle, but now I have to go further by t. And remember, t is this angle right here. So I'm going to go further by that. So it's actually going to be this rotation, because this part right here is t, and we added that to pi. Well, in quadrant 3, our y values are negative, so it'll be negative 4/9. Right, now the very last thing we're going to do is use our calculator to evaluate these functions. Notice that we don't have any degrees. You don't see the degree symbol, so we must be in radians. And if we're in radians, remember, we press the mode button, and we want radians. So to evaluate the cosecant of negative 5.2, we don't have a cosecant button. So what we would have to do is type in 1 over the sine of negative 5.2. So 1 divided by sine of negative 5.2. Close parentheses, and we get 1.132. 1.132. The cotangent of 3.7, that's going to be the 1 over tangent of 3.7. So 1 divided by tangent of 3.7, and we get 1.6006, so that would round up to 1.601. And then the last one, the secant of 1.8. Secant is 1 over cosine. So we'll do 1 over the cosine of 1.8. And that gives us negative 4.401. Negative 4.401. All right, so with this lesson, we talked about the shortcuts of using the even and odd functions that helps us in some instances evaluate without having to do coterminal angles. And then we learned how to use our calculator. So thanks for watching the video. Make sure to smash that like button and subscribe.